All right, we're back at it again, knocking out 5 more Network Plus questions. 5 more Network Plus questions to help you pass your certification exam. That's our goal today. Take a little bit of a deep dive into it, see if we can't answer some of these questions that you might see similar questions on your Network Plus exam. Let's jump right into it. Network Plus. All right, question number 1. You're tasked with designing a network for a department that requires at least 500 host addresses on a single subnet. Which of the following subnet masks should be applied to meet this requirement? We want to keep our answers quick. You kind of have to know this, right? I would fully expect to see a similar question on your Network Plus exam, something to do with subnetting. I think it's almost a given that you'll see at least one question associated with this. Without further ado, we're trying not to knock out 20 minutes on these videos. Let's see if we can't drag this down a little bit. Let's jump right into it. If you need more time, of course, you can pause it. We are tasked with designing a network for a department that requires at least 500 host addresses on a single subnet. Which of the following subnet masks should be applied to meet this requirement? Well, I feel like A is an easy one to get rid of, right? A is also known as a /24 CIDR. That /24 CIDR is going to give us a total of 254 addresses because we got a trap too, right? We need a network address and we need a broadcast address. That's going to give us 254 total IP addresses available per host. That is nowhere near 500, so we can get rid of that one. I feel like we can get rid of D too, right? We get rid of D. That's a /25 CIDR. That one is going to give us 126, right? So we take that 128 minus 2 for this network address and our broadcast address. Gives us 126 total IP addresses. Not going to be enough. Not going to be enough. So that's going to only be 126. That leaves B and C. B and C, a /22 and a /23. And remember, we want to do only the minimum, only what we want to do, right? So if we go through C, which is a /22 network, well, we know that one does 1022. Technically, it's 1024, but again, we need a host address, a broadcast address and a network address. So that gives us 122, or I should say 1022. Definitely does the trick. Definitely a correct answer. But what about a /23? Well, a /23 gives us 512, right? And that gives us 512 minus 2. That's going to give us 510. 510 exactly. And so B would be our correct answer on that one. B is all we need associated with that. And there we have it. There's B. All right, moving on. Question number 2. Question number 2. A network engineer installs a Wi-Fi network in a large open area, such as a warehouse. The goal is to ensure 360-degree coverage without using multiple access points. Which of the following types of antennas should be used in this scenario? I feel like this is one that you either know or you don't know. It really is, right? We remember when we go through Network Plus, you're really pressured for time. You really are. It's not a think about kind of exam. If you don't know the answer, I need you to flag it. I need you to skip it. Answer it, of course, right? You're always going to answer the question. I don't care if you guess, right? Remember, guessing, even if you have no clue, you still have a 25% chance of getting that correct answer, right? If you don't guess it and you run out of time, you have a 0% chance. If I can eliminate even one answer, it gives a 33% chance. If I can eliminate 2 answers, it gives me a 50% chance. Obviously, if I can eliminate 3 answers, well, then I know it, and it's a 100% chance. But let's answer this one, of course, if you need more time. Pause that video. Network engineer installs a Wi-Fi network in a large open area, such as a warehouse. The goal is to ensure 360-degree coverage without using multiple access points. Which of the following types of antennas should be used in this scenario? Let's get rid of a Yagi antenna. This is a directional antenna that focuses on a narrow beam. That's a Yagi antenna. We use this a lot of times when we're testing RF, when we're trying to figure out what's going on with a specific interference. We can use it for other purposes, but more often than not, that's what we're using it for. Obviously, a directional antenna means that we're doing a direction, right? Most times in cellular, we're looking at 120 degrees, some cases 90 degrees. And a directional antenna does a direction. It's not going to give us 360 degrees. That leaves us a parabolic antenna or an omnidirectional antenna. Well, if you understand that omni means all the way around, well, then you know the answer is omnidirectional. But why isn't it a parabolic antenna? Well, these are used for highly focused areas like long distance communication, such as microwaves. And so we see these parabolic antennas, they're highly beamed, right? Meaning they provide us a very long distance, right? Not really suitable for omnidirectional. Very much not suited for an antenna or a warehouse. There we go, omnidirectional. That's going to be our answer. Question number 3. An organization is planning to implement a wireless CDMA network for its mobile communication system. Which of the following statements accurately describes the advantage of CDMA in a mobile network? What do you think about this one? CDMA. Yeah, we're going into the cellular sphere a little bit. Trying to concentrate on some things that we don't normally do. That's our goal for today. Kind of throw that out there. What do you think on this one? CDMA. I was nice. I gave you the code division multiple access. I gave you the CDMA. Not to be confused with TDMA, time division. Not to be confused with FDMA, frequency division. CDMA. All right, let's answer this one. Let's start with D. A CDMA restricts the number of simultaneous users based on the availability of frequency spectrum. No, that would be more FDMA. That would be FDMA. C uses frequency hopping to prevent interference between different users' transmissions. Again, not something CDMA does. That's more of a frequency. Code division has nothing to do with frequency hopping. That leaves A or B. B dynamically allocates bandwidth to users based on the network's demand. Ooh, that's a good one. But what about A? CDMA allows multiple access to share the same frequency band by assigning each a unique code. Well, if you know CDMA, you know that A is the correct answer. B, dynamically allocating bandwidth to users based on the network demand. Well, that has nothing to do with CDMA. That is a whole nother technology. That's what that is. That's what we call DBA. DBA, not doing business as by dynamic bandwidth assignment association, something like that. But DBA does that. And so we know that it's going to be A. There it is. A is our answer. Moving on to question number 4. A network engineer notices that users on several VLANs are experiencing intermittent network outages and degraded performance. Upon reviewing network topology, the engineer discovers multiple switches are connected in a redundant loop without STP. No, I'm not telling you what STP is right now. Traffic analysis shows an unusually high volume of broadcast traffic. Which of the following is the most likely cause of the issue? I know, we went from 0 to hero overnight. Difficult question. Very difficult question. What do you think? What do you think on this one? The way I would approach this one, if I was like kind of stumped, right, I would look at the answers. I would look at the answers and kind of make my decisions based on the answers. I wouldn't try to figure it out from raw, right? Remember, we want to read the question, read the available answers, and then reread the question. What is the question really asking me? Not what I think it's asking me. That's not our goal. Our goal is to answer exactly what it's asking me. Remember, KISS, keep it simple, stupid. My favorite acronym associated with cybersecurity. All right, let's answer this one. A network engineer notices that several VLANs are experiencing intermittent network outages and degraded performance. Upon reviewing network topology, the engineer discovers multiple switches are connected to a redundant loop without spanning tree protocol. Traffic analysis shows an unusually high volume of broadcast traffic. Which of the following is the most likely cause of the address? I feel like we can get rid of A, IP address conflict between two core routers. That could cause specific connectivity issues, but not something wadcast, not something wide like this, right? And so definitely not something I would associate with this type of issue. Move to B. A malfunctioning switch causes a physical loop in the network. While this could cause problems, right, it doesn't lead to something that contributes to a loop, right? Not usually associated with that, right? And so when we look at this, it's not going to affect all of our VLANs like we're seeing here. So not really a good indicator, not really a good problem. That leaves D and C. C, a broadcast storm caused by redundant connections and no STP. Or D, A rogue DHCP server assigning incorrect IP addresses. Well, a rogue DHCP server could lead to some misconfigured devices, but it wouldn't lead to network flooding like we're seeing like this. That means it's a broadcast swarm. Well, a broadcast swarm occurs when we have excessive broadcast traffic on the network, often caused by switching loops. And spanning tree protocol is not enabled in this scenario. That means the redundant connections between the switches can cause the broadcast traffic to circulate endlessly, meaning we're constantly hitting ourselves with our own stuff. That's going to be our answer. Our answer is going to be C. Yes, I had to look up broadcast swarm. I'm not going to lie. I wanted to get the most accurate description of it. I kind of knew what it was, but I wanted to give you the up and up on it. I didn't want to make mistakes, right? So there we go. There it is right there. All right, question number 5. A security analyst is investigating why several critical servers in a data center have unsynchronized system clocks. This desynchronization is causing issues with log analysis, event correlation, and authentication across multiple systems. Servers are configured to use NTP to synchronize their clocks with a public time source. Which of the following should the analyst check first to resolve this issue? What do you think on this one? Yeah, another scenario based. Believe it or not, you should be able to knock this ones out, right? These are somewhat difficult on purpose. I wanted to be a little bit more hardcore with our questions this week. I felt like this was a good time to do it, right? All right, if you need more time to answer these questions, of course, you can always pause the video. Let's knock this one out. A security analyst investigating why several critical servers on a data center have unsynchronized system clocks. This desynchronization is causing issues with log analysis, event correlation, and authentication across multiple systems. We see this all the time. If I've got a seam on my network, everything needs to have the same time. If it doesn't, man, it's going to cause issues. It really is. We're not going to be able to utilize the tool the way it's supposed to. The servers are configured to use NTP, Network Timing Protocol, to synchronize their clocks with a public time source. Usually, in most cases with me, companies I work for, we synchronize to Greenwich Mean Time, specifically satellite time, GPS time, believe it or not. Which of the following should the analyst check first to resolve this issue? Let's start with D. Reboot the NTP server to reset the time synchronized pressure. Yeah, that's not going to work anything. Either the NTP is working or it's not. Resetting isn't going to do anything. That's that old adage that we have in IT, turn it off and turn it back on again. While it works in practical applications, in certifications, we don't. That's not a thing. That's not what we do. Not going to fix the issue. C, ensure that all servers are using the same time zone. I like this answer. I really do. Let's put this one on the back side. This might be a good answer for us. Check for IP address conflicts on the servers. I don't know why IP address conflicts have anything to do with timing. And so I don't feel like that's a good one, right? Could it cause connectivity issues? Yeah, it could, but it wouldn't account for our synchronization issues. And so B is out the window. Verify the firewall rules to ensure the MPP traffic is allowed. Ooh, that's another good one. So which of the following should the analyst check first? So we have C and we have A. Well, time zones are usually not a factor in synchronization, especially when we go to a public source. Right? If we're using a public source and if we read the question, the time zone, while it's a good attempt, it's not going to be the issue, right? And so we really have to understand what the question's saying on this part. And if you look at what the question says, it says the desynchronization is causing issues. If we look at the first part, the security analyst is investigating why several critical servers in the data center have unsynchronized system clocks. And then later down the line, we see the servers are configured to use NTP to synchronize their clock with a public time source. Public time source, that means that the time zone has nothing to do with what's going on. That means A is going to be our answer. It's the only one that makes sense. We need to verify the firewall rules to ensure the NTP is allowed. This would cause our issues. And so A is going to be our answer. There we go. All right, I hope you found this helpful. Until next time, I'm Dr. K. We'll see you again. Have a good one.